All right, here we go, getting ready for the first half of Chapter 4, the Chapter 4 mid-review here. And the first thing that we have is Section 1, that was from 4.1, where you have to decide whether or not the polynomial is a function, put it in standard form, state its degree, type, and leading coefficient. So as we compare the two, question number 1 and question number 2, remember for it to be a polynomial function, we're looking at the exponents, and the exponents need to be whole numbers, meaning they need to be positive and they cannot be fractions or decimals. So as we look at question number 1, we notice that the exponents are 1, 3, 2, and 0, essentially. And then on question number 2, we have exponents of 3, 1/2, 2, and 0. Well, in question number 1, all of the exponents are whole numbers. They're either 0 or positive numbers that are not fractions or decimals. On question number 2, you notice there is a fraction exponent, which means when there's a fraction exponent, that means it is not a function. And if it is not a function, you stop right there. You don't have to do the standard form or anything. So over here, when we have all of our exponents are positive and they are all whole numbers, that means that yes, it is a function. So when we write it in standard form, that just means we're going highest exponent to lowest exponent. So we are going to have 5x to the third minus 6x squared minus 3x plus 2. The degree is always just the highest exponent. So in this case, the highest exponent is 3. The type, just remember here, I'm going to put some little, I'm going to zoom in here for just a second. If the degree is 2, that means that it is quadratic. If the degree is 3, that means it is cubic. And if it is 4, that means it is quartic. Those are vocabulary words that you need to become familiar with, or should already be familiar with. In this case, the degree is 3, so it's a cubic function. And the lead coefficient, that's just the number in front of the first term in standard form. So in this case, it is 5. And then number 2, like we already said, was not a function, so we're just going to move past that. Now we just need to describe when this graph is increasing and when it is decreasing. So as we look at this graph, the increasing and decreasing changes at that line that goes right through the middle of that parabola. That line is at x equals 4. Anytime we're talking about increasing and decreasing, we are writing it as an inequality relating to our x values. So if we look, it is increasing to the right over here. This is where it is increasing. And it is decreasing over here. So over here it is decreasing. Which means if we're describing where it is increasing, it's related to x equals 4. Well, it is increasing to the right of 4. To the right of 4 is greater than, so it is increasing where x is greater than 4. And it is decreasing when x is less than 4. Again, whatever the change of direction is, at 4 in this case, that is going to be what you are comparing it to each time. As we look at number 4, we have 2 places where it's actually changing direction. We have here, right on the y-axis, and that is at x equals 0. That should be an x equals 0. There we go. And it is also changing direction here at x equals 2. So if we look at where it is increasing and decreasing, as we read the graph left to right here, it is increasing here to the left of x equals 0, and it is increasing also to the right of x equals 2, which means it is increasing when x is less than 0. That's that part that is to the left of 0. It is also increasing when x is greater than 2. That would be this part. The other section in there, in the middle, is where it is decreasing. So it is decreasing there in the middle. So it's decreasing when x is between 0 and 2. So remember, we write that as a compound inequality, where x is between 0 and 2, and we always point our inequality arrows towards the smaller number. So 0 is less than x is less than 2 is how we would write that. All right, so now we're just finding the sum or difference. And on the first two questions, all we are really doing, since there is addition in between there, that's addition sign, that just means that we are dropping our parentheses and combining our like terms. So if we identify our like terms here, we've got an 8x to the 4th power. That's the only 4th power. We've got a 3x to the 3rd power. That's our only 3rd power. We've got a positive 2x squared and a negative 5x squared. We've got a positive 7x, and we've got a negative 1 and a positive 1. So when we put those together, we are going to get 8x to the 4th. That's our 4th power, so we've done that one. The 3rd power, all we have is 3x to the 3rd. So we've done the green. Our x squareds, we have positive 2 and negative 5, which is negative 3x squared. And then we would have plus 7x, and we have a negative 1 and a positive 1 that's going to cancel. On the second one, we have a 4th power. We have 9x, sorry, I meant to highlight that. We have a 9x to the 4th and an 11x to the 4th. There's our 4th power. We have a negative 3x to the 3rd. We have a positive 4x squared and a negative 4x squared. We have a positive 5x and a negative 11x. And we have a positive 7 and a negative 9. So when we put those all together, we end up at 9x to the 4th and 11x to the 4th is 20x to the 4th. Negative 3x to the 3rd, that's the only x to the 3rd. It's a negative 3. So we've done our x to the 4ths, x to the 3rds, positive 4x squared, negative 4x squared, those are just going to cancel out. Negative 11x, positive 5x is negative 6x. Positive 7, negative 9 is negative 2. Next, we're going to move into subtraction. That's where we're finding the difference, which means we need to remember that when we have subtraction in between here, that means we need to change the sign to adding the opposite of everything that's in the parentheses after the subtraction. So we're going to change this to addition, and we're just going to change the sign of everything after it in the parentheses. So we're going to have 4x to the 3rd. It's the only 3rd power. We're going to have negative 12x squared, positive 8x squared. We have negative 4x, and we have negative 5 and negative 3. When we put those together, we get 4x to the 3rd minus 4x squared minus 4x minus 8. Okay, I'm just going to do this last one a little bit quicker. You want to take a look back at that one there. I'm not going to do all of the highlighting on this last one. So I'm going to change this to adding. I'm going to change the sign of everything after it, like so. And then we have 3x squared negative 1x squared is 2x squared. Squared. And then plus 11x plus 1. Okay, so we've added, we've subtracted, now we're just going to multiply. And I like to do the box method with multiplication. So I have a 3 by 2 because I have 3 terms in the first one and 2 in the second one. So I'm going to make my box a 3 by 2. Then I'm going to put my terms of my trinomial up above. So I'm going to have 2y squared. And then I'm going to have 4y, negative 7. And then on the other one I have a y and I have a positive 3. Then I'm just going to multiply, so I'd have 2y to the third, 4y squared, negative 7y, 6y squared, 12y, and negative 21. When I combine them, I get 2y to the third. If I put my y squareds together, I get 10y squared. If I put my y's together, I get 5y minus 21. All right, now for Pascal's triangle, you are going to need to know how to expand this out. Fifth power is probably the highest I would ask you to be able to do. The first thing that I'm going to do, I'm going to zoom in over here, and we are just going to write Pascal's triangle out. No A's, no B's, nothing like that. So we're going to use 1, and we have 1 and 1, 1, 2, 1, and I know I'm going to the fifth power, so as soon as I get to a 5 here, in my first thing here, I'm going to be able to stop. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Since fifth power is where I'm going, I can stop here. So now I know my coefficients. So I'm going to come back over here, and I'm going to put my coefficients down. So I have 1, 5, 10, 10, 5, 1. Okay, and then remember, as we start with our A's and our B's, our A's, it's the fifth power, so a to the fifth, b to the 0, so I'm not going to put b in there. And then my A's exponents start going down, and my b exponents start going up. So I'd have a to the fourth, b to the first, plus a to the third, b to the second, plus a squared, b to the third, plus a, b to the fourth, plus b to the fifth. So if you notice our pattern, if you're trying to think of how to pattern it, you have your a goes 5, 4, 3, 2, 1, 0. Your b goes 0, 1, 2, 3, 4, 5. Now you just need to substitute in your values. In this case, anywhere you see an a, you're going to put in a z. Anywhere you see a b, you're going to put in a 2. All right, so I have 1a to the fifth. So that means I'm going to have 1 z to the fifth plus 5 z to the fourth times b to the first. Well, that's 2 to the first power plus 10 z to the third, oops, not b, we're substituting, 2 to the second, plus 10 z squared times 2 to the third power, plus 5z times 2 to the fourth power, plus 2 to the fifth power. Okay, so we have it all expanded out. Now we just need to simplify. So my z to the fifth is going to stay z to the fifth, plus I can put together my 5 times 2, and I'm going to get 10x to the fourth, plus I can put 2 squared is 4. 4 times 10 is 40. Z to the third. Plus 2 to the third is 8. 8 times 10 is 80. Oops. Daisies. Is 80 z squared plus 2 to the fourth is 16. 16 times 5 is 80. See daisies. Z plus 2 to the fifth, which is 32. So when it's all expanded out, you have all the way from the fifth, oh, and I used x there, that should have been a z. 5z to the fifth plus, that should have been a z, not an x, z to the fifth plus 10z to the fourth plus 40z to the third plus 80z squared plus 80z plus 32. Okay, now for some long division. All right, this is not synthetic division on this first question. Okay, so make sure that you realize you can't use synthetic division unless what you're dividing by is a simple binomial like x plus 2, x minus 5, something like that. So the first thing we're going to do is we are going to put what we're dividing by on the outside of the house. So I have x squared. I have x squared plus x plus 4. And then on the inside of the house, I have x to the fourth plus 3x to the third minus 4x squared plus 5x plus 3. And I didn't have to do any space fillers here. I have a fourth power, a third power, a second power, a first power, and a constant. So everything is fine with that. The next thing we're going to do is I'm going to take my first term and my first term. And I say, how many times does x squared go into x to the fourth? It goes in x squared times. So I'm going to put my x squared up here above my x squared column. And then I'm going to multiply through. X squared times x squared is x to the fourth. X squared times x is x to the third. And x squared times 4 is 4x squared. Now what I need to remember to do is I am subtracting, so I need to change the sign of everything before I combine. My x to the fourths cancel. 3x to the third minus 1x to the third is 2x to the third. Negative 4x squared, negative 4x squared is negative 8x squared. And then I need to bring down my next term, which is 5x. And then I go back and I do the same thing again. I say, how many times does x squared go into 2x to the third? It goes in 2x times, so I put that plus 2x up above my x column, and I multiply everything through again. 2x times x squared is 2x to the third. 2x times x is 2x squared. And 2x times 4 is 8x. When I go and I change my signs, that means I have negative, negative, negative. My x to the thirds cancel. I get negative 10x squared minus 3x, and I bring down my 3. And I do the same thing again. How many times does x squared go into negative 10x squared? Well, it goes in negative 10 times, so I can put negative 10 up here on top, and I multiply all the way through, and I get negative 10x squared minus 10x minus 40. Again, I got to change my signs. Everything is the opposite. So I get 7x plus 43. Once I get where there's nothing else to bring down, that 7x plus 43 is my remainder. And it comes up here 7x plus 43, and I put what I'm dividing by in the denominator, x squared plus x plus 4. And there, up here, that is your answer. All right, synthetic division, if you remember, was a way faster version of long division. But again, in order to use synthetic division, you have to have a simple binomial that you are dividing by. So remember, when we have synthetic division, I'm going to put my house upside down like that. If I have x plus 4 that I am dividing by, I put a negative 4 on the outside. I put my coefficients on the inside of the house. In this case, I have 1 x to the 4th. There is no third power, so I have to remember to put in a 0 as a filler. Negative 1 x squared. There is no x, so I have to put a 0 in as a filler, and then a negative 7. Step 1, I bring down my 1, and then I just multiply, fill in the spot, and add. 1 times negative 4 is negative 4, and I add. 0 plus negative 4 is negative 4. Multiply again. Negative 4 times negative 4 is 16. I add, and I get 15. 15 times negative 4 is negative 60. 0 plus negative 60 is negative 60. Negative 60 times negative 4 is positive 240. And 240 minus 7 is 233. We started with a 4th power, which means our first term is going to be a 3rd power. So we are going to have 1 x to the 3rd power minus 4x squared plus 15x minus 60. And our remainder is 233 over x plus 4. We just take those numbers that we got on the bottom of the house, and they become our coefficients of our answer. All right, kind of gave you some hints over here on the right-hand side. These hints will not be on the test. Okay, it's not going to tell you how to actually factor it. So we're going to start by the first one here, question 13. And we have 64x to the 3rd minus 8. That's a difference of 2 cubes. We have a 3rd power, which means we want to write 64x to the 3rd as a cube. So we're going to have 4x to the 3rd power minus 2 to the 3rd power. If we remember our formula, if it's the difference of cubes, we'd have a minus b, a squared, opposite sign, plus ab, always positive b squared. So now we're just going to fill in the a's and the b's. A is going to be 4x, b is going to be 2. So we're going to have 4x minus 2. 4x squared is 16x squared. You can't forget to square both parts. Plus 4x times 2 is 8x. And 2 squared is 4. And then you are done. And you just have to remember that formula. And if you don't have it memorized, then be able to recreate it one way or the other for the test. Number 14 has 4 terms, which tells me I want to look at grouping. All right, if I look at 2a to the 3rd and 7a squared, I can divide out an a squared out of both of them. So I'd have a squared on the outside, and I am left with 2a minus 7 on the inside. If I want 2a minus 7 left over on the inside on that second group, I need to take out a negative 4. So then I have 2a minus 7. And 2a minus 7 is one of my factors. The other factor is a squared minus 4. Anytime my leftovers that I have factored out and I have something that is squared left, I have to ask myself, can I factor that any further? And in this case we can, because a squared minus 4 is the difference of 2 squares, which means our final answer is going to be 2a minus 7, and that a squared minus 4 factors into a minus 4, or excuse me, not a minus 4, a minus 2 and a plus 2. So that should go right up here. And the last one, 16n to the 4th minus 25. Okay, that is the difference of two squares. 16 is a perfect square, 25 is a perfect square, which means I am going to break it apart into two binomials. And I'm going to have the square root of 16 is 4. It's going to go in both of them. Since we have a 4th power, I need to break that 4th power up evenly. So I'd have 4n squared and 4n squared. Square root of 25 is 5, so I'm going to have minus 5 and plus 5. And there you go. Hopefully this video helped you just a little bit, and good luck on your test tomorrow.